Okay, we're going to have a look at some change of base logarithm questions. Now this kind of question can be the bane of a poor Year 12 method student's life. So take heart, there usually is a way of just picking through all of the algebraic mire and basically working out what to do. So hopefully with me doing these numbers, 7, 8, 9, 10 and 11 from exercise 5F, in the Essentials textbook, this might give you a bit of a clue as to how to approach these knotty problems. Now if we have a look at number 7, we can see this very, very peculiar looking equation which we've got to try and sort our way through. Now, but there is a clue here. You can see that there are 3 terms on the left hand side and there are 3 terms on the right hand side. Now it just might be that the left hand side first term corresponds with the left hand side right term, and so I would say that's a safe enough path just to pursue just to see whether you can make some logic out of that. Now there's another key thing which I've noticed here, and that is, do you see the first term on the left hand side has a base of b, and the first term on the right hand side has a base of a. So this tells you there's got to be some change of base happening here. And then if you then see on the right hand side, gee, that's a base of a. Now look at the numerator, that's 1. Now if we're looking at a change of base, it's probable that that is a log term in disguise. So if we're looking at base of a, in other words, we've changed to a base of a, that term just might well be the log of a to the base of a, which would correspond exactly to a change of base of the left-hand side first term. Now let's just go through that, okay, and see what we get. But that's what I'm picking up from that question. So yes, we need a change of base, and let's just pursue it, okay? Okay, so now what I've done with that left-hand side first term is I've changed the base from B to A, okay? We're halfway there. So, and then we've got the second term where we've changed the base similarly to B because of the denominator on that second term on the right-hand side. You can see they've changed the base to B. And similarly, the third term, we've changed the base to C. We're about 90% there now. So let's see what happens now. Okay, the left-hand side is equal to, as I said, just repeating that from the previous screen. Now, you can change the numerator of each of those 3 terms to 1. So here we go. How marvellous. And then that is equal to the right hand side as required, and yes, we did it. Isn't that great? So it wasn't so hard after all when you just sort of think about what you're doing and have enough confidence just to sort of see through the camouflage. Okay, now let's have a look at question 8. This one at first glance looks pretty revolting, and you just wonder, well, what am I supposed to do here? Well, let's have a little look at it. We're supposed to, if we know that the log of p to the base r is q, and the log of r to the base q is p, which all sounds very mixed up, we've got to prove that the log of p to the base q equals pq. Well, if you just take a few moments to look at that, I don't think I really want to start on the left-hand side of that thing that I have to prove. It would probably be easier for me to start with the right-hand side and just multiply p by q in terms of the terms that I've been given there. Now, so that's what I suggest we do, and then just put one foot in front of the other, don't get all flustered, and just see what happens. So here we go. Yes, this is my frustration. How do I start? But we've decided to just go with the right-hand side and see if we can make that equal to the left-hand side. Yes, and we do need change of base. Okay, here we go. Start with the right-hand side, as I said. Okay, so P times Q is equal to, according to the information they've given us. Now, if you have a look at that, we're supposed to be trying to prove that that equals to the left-hand side, which is the log of p to the base q. So my instinct would be that second term has got log of p in it, but it's got a base r. So why don't we change that to a base of q and see where we end up? Here we go. That's it. That's what I'm doing. That's what I just said. Now, okay, yeah, that's what that term there is what we've got to try and get to, okay? Now, so we'll change the second term to give it a base of q. Here we go. Oh, well, that's very interesting. Now, when you look at that, you can see that it's just fallen into our lap. We can cancel top and bottom, and we'll end up with the answer. Isn't that great? See? Easy as. A done deal. So, wasn't so hard. Now let's go with question 9 and see what that says. Now we're on a roll. We're saying that if u equals log of x to the base 9, find in terms of u 3 things. First of all, x log of 3x to the base 9 and log of 81 to the base x. Okay, let's go with the first one. That's a. Alright, here we go. So we're saying u, that's the given that we're given at the start of the question. Now, all you've got to do to find x is rearrange that equation, rearrange it so that we put it in the traditional way that I like to say, that is the base to the index equals the number. So let's do that. There's the index, which is the log, there's the base, and here is our number. So let's rearrange that now into the way that we're more used to doing this from earlier years in secondary school and see where we end up. Okay, base to index equals number, which gives us 9 to the u equals x. So, and they asked for the thing in terms of u. So I think we've done it. X equals 9 to the u. Hey, that's not so bad, is it? So that's the first one done. Okay, here we go again. This is now part B we're going to do now. Okay, we have to find that the log of 3x to the base 9. Well, that 3 is a bit of a problem, isn't it? I don't like the look of that 3 much. But then when you think about it and look at it for a few seconds, you can kind of get out of that, well, if I could just get that 3 out of the road, this thing would be a lot more pleasant. And you know that the laws of logs say that the log of one thing times another thing is equal to the log of the first one plus the log of the second one. So that's where I'm going to go with this and see where it takes me. Yeah, that 3 is a problem. So, now, that's what I'm trying to do. Now, that's giving me a lot of joy because the second term is exactly equal to u. The first term, we have to work out what that is. Now, can you spot what that first term is equal to? What is the number 3 in terms of 9 to the something? Because that is the log. Here we go. Yeah, 3 is 9 to the half. So the log is a half. And there's your answer. Hey, not so bad. Quite easy, really, when you just sort of put one foot in front of the other and don't lose your cool. Now, here's the last part of this question. What have we got to do with this one? Okay, log of 81 to a base of x. I think I smell a change of base here because we've been dealing with base 9 so far. So why don't I just change that into log of 81 to the base 9 over log of x to the base 9. That's right. Change of base. Yes. And there it is. Now, what is the log of 81 to the base of 9? Can you think about that? Because we already know what the denominator is. That's just equal to u. So here it comes. Yeah, of course. 81 is 9 squared. So the log of that is the index, which is 2. So the answer is 2 over u. Wow, it's pretty good. Okay, now we're well and truly on a roll now. Let's see if we can do question 10. Now, what are they saying? Solve log of x to the base 5 is equal to 16 log 5 to the base x. Well, you see the bases are different. Hey, we're going to have to do a change of base here for sure. Now the question is, which base are we going to change to? So, are we going to change both bases to 5, or are we going to change both bases to x? Well, the answer is I'm not sure, but my instinct tells me it's probably better to go with a base of a number rather than some pronumeral. So why don't we try that? So that would say that my strategy would therefore be that I've got to leave the left-hand side as it is, and I've got to change the right-hand side log term to a base of 5. So let's go with that. Yes, we need to change a base. Yes, we do. And there I've done it, okay? So, now, that looks great to me because I can see that the denominator of the right-hand side is exactly the same as the left-hand side, and the numerator of the right-hand side is just simply 1. So that's made it a lot easier. So let's just take that a bit further. My goodness. So, what are we going to do with that? I think I can smell a square root happening here. Yes, that's pretty good. Now just let's examine if that actually makes sense. Can you have a log of something equaling to a negative number? Yes, you can. You certainly can. It's just that you can't have the log of a negative number. That's okay. So what we've written there makes sense to me. Okay, here we go. So that's telling us if we rewrite those equations in terms of the traditional method, base to index equals number, there we've got those two statements. And we just have to solve them for x. Okay, the first one, okay, and there's the second one. I've just rewritten them for you now. Okay, here comes the first one. That is 5 to the 4th is 625, and the second one, 5 to the minus 4, is 1 over 625. So there you have it. That's the answer. Wow, it's very, very good. Okay, here we go. Last one. So if, wait a minute, what does that say? Okay, now if we have a look at this, we've got that q to the p equals 25, and the whole thing looks very confusing. But what I'm noticing is that the right-hand side, we're asked for log of q to the base 5. So, okay, well that's pretty interesting. So that tells me, I think, that we've got to be using base 5 on the left-hand side as well. So why don't I just take the log of both sides and see if that gets me anywhere? Okay, let's do that. Very interesting. So therefore we're saying that p log q to the base 5 equals log of 25 to the base 5. Now, this is looking good because I know you're looking at the right-hand side and you're saying to yourself, that right-hand side equals 5 squared to a base 5, and that's going to be 2. Gee, now that's helpful. So therefore, now what are we trying to get here again? Let's have another look. Okay, yes, looking up the top we can see we're supposed to get log of q to a base of 5. Well, I think we've done it, because all you've got to do now is divide both sides by p to make log q to the base 5 on the left-hand side the subject, and what do we get? My goodness, we've done it. That's fantastic. So I think that's everything now. So there you are. You see, they weren't really all that hard after all, providing you just have enough confidence to trudge your way through the mud and not lose your cool, and just look for the clues. Okay, thanks everybody.